Hello, I'm going to explain uniform circular motion. What is uniform circular motion? So, when the velocity of an object changes, when the velocity of an object changes, we say that the object is accelerating. Means acceleration is produced when there is change in the velocity. The change in the velocity could be due to change in its magnitude or direction of the motion or both it is here. Okay, when there is change in the magnitude or change in the direction, in both cases, okay, if both is changing, then there is change in its velocity and we say that the body is accelerating. Suppose if the magnitude is same, what is magnitude? Magnitude means like 5 kilometer per hour, 10 kilometer per hour. So this 5 magnitude is related to the number 5, 10 like this it is here. Suppose when the magnitude is same, only direction is changing, even if the body is accelerating. Okay, so there is change in the velocity here, if only direction is changing here. So this type of example is a circular motion it is here. In circular motion, what happens? Even if the body is moving with uniform velocity, each and every point, the body is changing its direction, and that is why uniform circular motion is an accelerated motion. Just I will show you the figure. Suppose there is a track. This is a rectangular track is there now. This is a rectangular track, and athlete is moving on this track. The velocity is uniform. Okay, means velocity is not changing, it is here. The magnitude of the velocity is not changing. Only so when it's moving in this track, the athlete will have to change 4 times. Okay, its direction will have to change 4 times from A to B, B to C, C to D, and D to A. It is here. It's changing in direction. Okay, if the athlete is moving in this hexagonal track, then the body will have to change its direction 6 times. A, B, B, C, C, D, D, E, F like this it is here. Okay, suppose if the sides are made smaller and smaller. Suppose this is octagonal. In this case, the body is changing its direction 8 times, right? And even if the next example is this circular one, the circle here now. Okay? If you go on making the sides smaller and smaller, ultimately we can get a circle. So each and every point on the circle, the body is changing its direction. Just you can see in the figure here, this figure it is. Okay? Therefore, the body is accelerating. Even if the magnitude is same. Magnitude is same means if the body is moving with uniform velocity, like suppose 5 kilometer per hour it is here. Okay, it is moving with 5 kilometer per hour. Okay, all through the track. Okay, then while moving here, it is changing its direction. It is here. Then even if the body is accelerating here, so we can say that if the athlete moves with a velocity of constant magnitude along a circular path, okay, the only change in the velocity is due to the change in the direction of the motion. The motion of the athlete moving along the circular path is therefore an example of an accelerated motion. Okay, yes, just I'm showing you now here how it is here now. Suppose we know that the circumference of a circle of a radius r is given by 2 pi r. It is 2 pi r is okay. The circumference of a circle of a radius r is given by 2 pi r. If the athlete takes t seconds to go once around the circular path, of radius r, the velocity v is given by v is equal to 2 pi r by t. The velocity v is given by 2 pi r by t. What is 2 pi r? 2 pi r is the circumference and t is the time taken to move, okay, once around a circular path. So, okay, so in this way we can find the velocity of the body, okay, moving along the circular path. So when an object moves in a circular path with uniform speed, its motion is called uniform circular motion. Right? I think you have understood it. That's okay, fine.